Let's take a second closer look at the AC-15 hand wire that Vox has come out with. I've gone through the entire circuit, drawn it all out. I know everything's happening from here to the very other end of things. Everything except for what they're doing on the effects loop. More on that in a moment. And overall, it's pretty close to what JMI did back in the day, minus the tremolo circuit, with the addition of reverb. There's some places where they deviated in frankly dumb ways. We'll get to that. There's some places where they deviated in fairly clever ways. Let's start with one of the clever ways. Traditionally, the normal channel of an AC-30's got a 220K plate resistor right here. And then that goes to the triode plate. And off that is also, in the original, a 47 nanofarad. Here is a much better sounding 10 nanofarad. I applaud this choice, demuds it. And then that goes to the normal channel volume. But what they've done here is they have this LND 150 MOSFET in series between this plate resistor and the triode plate, and the boost switch shunts this MOSFET. And what they're doing is when it's non-boosted, you have just a straight triode connection. The tube behaves like a one triode of a 12X7. When this is switched to boost and this MOSFET is in series between the plate and the triode, it behaves like a cascode tube circuit, which gives a sound and gain response not too dissimilar from a pentode. So it's a way to make this sound very much like an EF86, very simply. Now, I don't think it nails all the aspects of it, and I think maybe down the road I might tweak this a little bit and see if I can refine it, but it's a pretty good use of an LND 150. It's very clever of them, and I applaud them for that. Looking at the top boost circuit, they've got the 220K plate here you'd expect, and it's going straight to the triode of V1B. And off that, on the originals, they had a 500 picofarad cap. I've changed this one out to a 470 picofarad because from this factory, they had a 1 nanofarad here, which has got a little more low mids than the traditional circuit, and the traditional circuit sounds really good. Now, before we move on, originally, V1A and B shared a cathode in the old AC-30s that this is based on. Here they have split it, and I discovered that they have to split it because if you have a shared cathode, the cascode circuit falls apart, sounds awful, the boost goes away, and sounds really, really bad. So they have split the cathode. Now, traditionally, the values in the cathode on an AC-30 be 1.5K and 25 microfarad. And if you split that, you would double the resistor, so 1.5K becomes 3K, and you'd have the capacitor, so 25 would become 12.5, 10 microfarad is the nearest standard. But they didn't do that. They had 1.5K, 1.5K, 22 microfarad, 22 microfarad. I have changed this 1.5K to a 3K or a 2.7K, I don't recall which I used. You non-colorblind people in the comments will be telling me what I used here. So this top boost channel is going to respond more like the old ones did. I left the 1.5K here. I think this circuit with the cascode needed that bias level. I have changed both 25 microfarads, including this one over here on the top boost driver tube, from 25 microfarad or 22 microfarad, in the stock amp to 4.7. Still has tons of lows. Everything above 40 hertz is left untouched. Just takes some of the sludge out, makes the amp more efficient. It's a nice change to make in a non-vintage amp. Now, the vintage ones had 30 microfarad for the top boost circuit, 10, or actually 8 for the preamp. This has 10. I've changed this one to 20 instead of the 10 that was here, just to give a little more filtering to the top boost circuit because there's a good bit of gain there that it adds in. There wasn't really room for a 30, but this fits just fine. This is a 500 volt cap rated for 105 degrees. This 10 that used to be here was a 350 volt cap rated for 85 degrees. Now this is kind of a generic cap rated for 85 degrees. This is a cap I trust rated for 105 degrees. So I do have some 10s on order that will be going in here and one other location in the amp. But if you have one of these, you don't have to have someone do all this. You can keep the stock electrolytics. You can keep, including the cathode bypass caps. You don't have to change those. I would suggest having someone change this from 1.5K to 2.7 to 3.3K, somewhere in that range. I would suggest having a tech change out this 1 nanofarad for a 470 picofarad or 500 picofarad. Makes subtle differences, but a useful difference. Next, I'll show you the things that really make a difference in this amp that you really should have done. Here's the tone stack, and it is a cathode follower tone stack, so 56K off the cathode. And from there, they've got a 47 picofarad going to the treble pot. And then they have 100K for the slope resistor. Well, no, they don't. I put in this 100K. They had a 220K for the slope resistor. And then they had a 10 nanofarad and a 22 nanofarad. The original had 100K, 2222. They changed it to 220K, 1020. And that really took away any ability of the treble and bass knobs to be interactive and control the amount of mids that the amp should have, which is a crucial part of playing an AC-30. That big scoop of the 220 just made them too independent of each other, made it a bit too Fender-like in my opinion. The world is full of great sounding Fenders, but this needs to be a great sounding Vox. And I don't know why they messed with the winning formula. So if you get one of these, 22, 22, 100K, very important in this area, changes the entire sound in response to the amp otherwise. Now, right after it, we've got these 220K resistors from here to here, from here to here. This is the output of the normal channel. This is the output of the top boost circuit from the wiper of the treble pot. And they're being mixed together to this point right here. This goes off to feed the effects loop, and I'll tell you where it goes after that in just a moment. In stock form, there's a 68 picofarad cap across the 220 mix resistor coming from the normal channel. And that cap made the normal channel very slightly brighter and the top boost channel very slightly darker. And I lifted one end of it out and in and out and listened, and it's very, very subtle, and you can leave it alone if you wish. You can leave that cap in place. I found that while the change was subtle, it was not subtle in a direction I preferred. I like the top boost to be a little bit brighter, and I like the normal channel to be a little bit smoother. So I took that cap out. That's why this 220K is off to the side a bit. After the signal comes out of that mix stage, it goes to the effects loop. It's a hardwired bypass on the switch. It comes back and it goes to two places. It goes right here, which is the input of the phase inverter on this side. It's one of the phase inverter inputs. And they had 100 nanofarad caps on the phase inverter inputs, which is a dumb idea in a AC anything. I've changed them to 22s. Much better not to have all kinds of flub potentially being introduced here. I don't know why they did that. It's a strange thing, especially since they have 10 nanofarad output caps. There's no need to have 100 nanofarad feeding the input of essentially a 2 meg input impedance circuit. It's just asking for noise to be picked up. So I've changed that out. But it also goes with the diagonal here. And this is the input of the reverb driver circuit. So it's got some attenuation through this 1 meg. And then it goes to this cap and blah, 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 blah. I don't want to draw the whole thing out for you. That goes to a 12X7, which is being used as a cathode follower. And the cathode of that is then feeding a 12AT7, which is tied to the reverb transformer. And so the output of the reverb transformer goes to the RCA send. The RCA return has this 220K across it to ground. And then it goes to V3B. And here are the components for that. Here's the cathode. Again, I changed out for the vis shade just for higher quality. Plate, a little dropper from the screen supply. I increased this filter cap to 20 microfarad as well, just to give some stability in that. It's got its own plate resistor here, which is going to the reverb pot. The reverb pot's got a circuit kind of like a 5E3 Deluxe to boost or cut lows, which is kind of useful. And then the wiper of the reverb pot comes out to the other side of the phase inverter. Because this amp does not have negative feedback, both sides of the phase inverter can be used as inputs as once. They are out of phase with each other, but since it's just the wet stuff from the reverb coming back in, that does not matter. The phase inverter is exactly what you'd find in a JMI, 47, 1.2, 1 meg, all that fun stuff. And I will be changing out this 10 microfarad cap for an MOD, just like I did the others. But like I said before, I'm out of the 10s right now. So all the way up to here, we've explained everything. Well, I haven't really told everything. I don't think most people care to know what all these bits and bobs here do. It's reverb driving stuff. Oh, and this big resistor here is the unbypassed cathode resistor for the 12AT7. Now, in the first video on this amp, I mentioned that the master volume was lacking some 2 or 2.2 meg resistors from lug 1 to lug 2 on either side to protect the tubes in case the pot were to fail, to give a bias reference. I was incorrect. They're actually here. So they mounted them here instead of on the pot, which would have been a little more intuitive. But this works too. There's nothing wrong with this. So here they do have the protection. Good on you, Vox. So Vox gains a point here, and then they lose a point here. These are the screen grid resistors, and in stock form they were 100 ohm, which is just stupid. It's the same stupid thing you see in everyone who copies old Voxes. JMI got away with it in 1959 because they shipped with Mullards and Brimars and really excellent tubes we can't get anymore. That 100 ohm resistor just gives no protection to modern tubes, and they die, and they burn up. So I've changed it to 1Ks, some little 2-watt 1Ks, which is what I do in most Voxes that come in. You won't hear any or feel any negative difference. You probably won't hear or feel a difference at all. If you do feel it, it might be a little nicer compression, the way it responds to the right-hand dynamics. But your tubes will last a lot longer. Now here in stock form, they had 32 microfarad, and then they had a 10 microfarad and a 4.7 microfarad. I've changed it both to 16. It gave us a gap here, which gives a little more air around the cathode resistor, which can get warm. There's no hum or ripple in the output, and the behavior of an AC-15, AC-30 with the lower filtering is more correct. And since this amp has a choke, I can get away with it. I had to do something a little bit different on the AC-10, as you'll see. But I'm quite pleased with this overall. I also bumped up the 47 microfarad here to another Vichy, just so that all the electrolytics when this thing goes home will be known quality, either Vichy or MOD. This thing had a noisy effects loop when it came in, but it was quieter than the one in the 10. And I have played around with the lead dress because there's a lot of wires that are close to each other in here. And I have taken everything apart. I looked at this, and this thing has got through hole on top and a lot of SMD on the bottom. It's got more components on this little card than there are in the rest of the amp, I think. And while I am capable of tracing all that out, it would be very time consuming to do because it has traces on the bottom, traces on the top, and vias that go back and forth. It's jumping all over the place. If Vox wants to furnish me with a schematic, I'll be glad to take a look at the schematic and do their homework for them and see what the mistake. There's a mistake in this circuit. It's noisier than it should be. However, like a lot of Voxes, they've got little metal tabs that are soldered to the board that fit over the ends of these jacks and are pressed up against the exposed metal of the chassis on the other side. And they've got some caps that act as filters, so there's RF protection from that metal-to-metal contact, even though it's not tied directly to ground. Getting all this off, cleaning all that metal that makes contact with each other, putting it back together, getting everything tight has made a big difference. That plus some lead dress adjustments. And now if you use it in +4, it's almost unnoticeable compared to bypass. You're still going to hear a hiss increase when it's at -10. So it's far from perfect, far even from being very good, in my opinion. But I have addressed a lot of those issues. Speaking of addressing things, people in the first video said that Vox had forgotten to put a nut on this little switch. This switch is designed not to be screwed into the face. It's not supported by a panel. It's a metal tube. It's all supported on the board. I don't expect that to be a problem. It could be a little bit better if it did have a threaded connection, but it doesn't. So, that's how the part was designed, just for those who were curious. I've got the wooden panel off, which is not something that most owners will ever find themselves needing to do. You don't have to do that to change tubes. But if you're a tech and you have to take off the wooden panel, you do have to remove the 2 screws that hold this little fan in place. It's a brushless motor, little computer fan, just blows on the tubes. It's quiet, unobtrusive, not a problem. Sadly, there is no way to disconnect it. It's hard soldered to a board that's in here where the fuses are. It's just a little bit of a pain in the butt for a tech. No big deal otherwise. Inside, we've got a GZ34 tube rectifier, and they're pulling the B+ off the proper pin 8. A lot of previous Voxes, some of the custom classics, and almost all of the TBXs got that wrong. A pair of EL84s, with the grid stoppers mounted right here. Everything's fine here. Let's see, coming from the input, the normal channel goes to this half of this 12X7, and the top boost goes to this half, and then the top boost tube here are the two halves of this 12X7, and then that's all mixed together, and it goes to the loop with the hard bypass. And then it goes and it splits off, and some of it goes off to half of this tube, which is the reverb buffer. It's a cathode follower, which then feeds this 12AT7, which is the actual driver connected to the transformer for the reverb. The reverb comes back to this other half of this 12AX7 and is mixed on the right side of the phase inverter, and the dry output is mixed on the left side of the phase inverter. With an amp without negative feedback, you can do that. And then this is the phase inverter tube, another 12X7. So 4 12X7s and a 12AT, 2 EL84s, and 1 GZ34. Everything's done very neatly. Most owners will never need to go in here, which is a good thing. And if you saw part 1, you know that I was not happy with the external connections for the cabinet speaker, because that would get sheared off. It is nice that they are physical jacks, not mounted to a PCB, so when, not if, but when someone shears one of those off, it'll be a relatively easy repair. But to make life easier, I have installed another cliff jack here for the internal speaker, and I've got a nice centered 1-inch hole drilled through the wooden panel, and all will be well. And here's what that looks like with a little hole saw and some flat black spray paint. Ooh, fancy. Of course, they could have done this from the factory very easily, which would have been the right thing to do, but who am I to say? And here's another look at that cool Tron fan, which is mounted on little grommets, so should not have any vibrational issues. All right, after those changes, what's the effect on the sound? Well, on the normal channel, aside from the global changes the filtering are going to offer, including decreasing the noise in the reverb circuit, the only thing I did that's really going to affect anything is that I decreased the real ultra lows by changing that cathode bypass cap out, but you're not going to hear it on guitar. I can't do anything about that pop because it's changing the operational state of that tube. If that bothers you on stage, turn the volume down before you hit the boost switch so you won't get much of that pop. It is what it is. When both of these amps are done and I do the final video, I'll show some humbuckers. This channel has got some grunt that this Strat is not going to really demonstrate. Let's do the top boost. So the mid-range control, as you move the treble and bass knobs, is back. If you like the stock amp, that's great, but it's not really doing anything that Voxes have ever done. Make those few changes I showed, and all of a sudden this behaves more like a Vox. A note to anyone who's played with the JMIs, the modern amps have these wired clockwise, the JMIs have these wired counterclockwise, and because they are audio taper pots, the O-clock positions on the new ones don't correspond to the O-clock positions on the old ones, but the sounds that you get out of them can be the same. I noticed that I was not just working treble and bass, but also working that top cut knob. And then when I was on the normal channel, I turned that top cut down quite a bit. And on the top boost, I bring it down quite a bit, or up from your perspective. Given what I'm just demonstrating, I had the master volume at 1 o'clock for all this. It does sound better on 10, but it's getting towards the end of the day. People are feeding their families and stuff. I don't want to be that guy with that really loud house. Yes, a 15-watt amp on 10 is loud. Let's turn our attention to the AC10. I mentioned earlier in the video that when you split the cathode that's normally shared in an AC30, you've got to double the resistor value and halve the capacitor value. So in the original, it was 1.5K, bypassed the 25 microfarad. To do the math properly, this should be a 3K, bypassed by about a 10. And this is a 3.3K, which is close enough to 3, but they had a 25 here. I've gone to a 4.7 just to tighten up just a slight bit, because the original circuit does have an awful lot of low end. But nominally speaking, 3K and 10 microfarad would be the proper split. This 3.3K and the 4.7 will be kind of the optimal split. So that takes care of the cathode side of the first triode. Over here, we've got the 220K plate resistor, and it's a 22K dropper from the screen supply. And it's filtered here with a 10 microfarad. More on that later. And then it goes to the tube, and then it goes to this 471 picofarad cap. And it used to go through a 220K resistor and then to the volume pot, which has a 120p bright cap across it. That 220K that was here really limits the gain range of that pot. It's like a pot that can never go over 7. So I replaced that 220K with this 47 ohm just to span that gap. If I could have just done some straight wire, but this is fine. And so now you have the full range of the pot. So it's not handicapped to be quieter than it otherwise would be. I don't know why they did that. Makes no sense to me. The wiper of that pot goes to the second triode's grid, and that triode is a 1.5K, bypassed originally with a 22 microfarad. I've got it bypassed with another 4.7 just to tighten it up. By tightening it up, I mean it's flat down to like 30 hertz. You're not losing any lows, you're just not getting the flub down below 30 hertz. And then that plate on this side is coming from the same node here, formed by this 22K. It's 100K, bypassed with a 471 picofarad. That's something that I used to do when I was modding the AC-15 TBX series, which is also a plate-driven tone stack. It just kind of smooths out some of the ultra highs, makes this feel a little bit more like and sound a little bit more like the cathode follower version of the tone stack, though you cannot get it exact. Anyway, so on the other side of this plate resistor, not only does it go to the tube, of course, has this 47 picofarad going to the treble, and then it has a 100K slope resistor and two 22 nanofarad caps. Now, I would not have changed these caps if Vox had not burned the hell out of this one in the process. So they'd really mangled this one up, and this one wasn't that great. It looked like it had too much heat applied to it. So I've got two Vichy new caps here without any burn marks or overheating. And one of the ways you can do that is when you're soldering, you just use something as a heat sink. So that's not going to overheat that cap if I'm soldering on that end of it. All right, so it goes to the tone stack, and the tone stack is wired correctly. And then the wiper of the treble pot comes to right here with a 220K and then another 220K to ground. That emulates the mix resistors of an old box. And from this point, it goes to the effects loop. And from the effects loop, it then goes to the input of the phase inverter here on this side. It's got a little 10 meg to ground there just in case just eliminate switching noise. That's not doing much other than that. And it also goes from this input capacitor here to this 471 picofarad cap here, which is the input of the reverb driver stage. And it's doing that with a MOSFET, a power MOSFET, which is tied to the transformer. So this behaves in some ways like a 12AT7. And I'm not going to bore you with all the particulars, so I've drawn it all out. And then from the RCA jacks, it goes to this bit of circuitry right around here, which is using an L&D 150 as the recovery gain stage. It was functioning kind of like a triode. And that is all going to the reverb pot, and from the reverb pot, it goes to the other side of the phase inverter because this amp has no negative feedback. Both sides of the phase inverter can be inputs which are mixed within the phase inverter. Now, I mentioned in the previous video on this amp that it lacked a cut circuit, so there was no treble attenuation in the output the way there is in most Voxes, including the AC-15 version of this amp. And some genius was like, oh, he plugged a telly into a Vox and complained it was too bright, hardy, har. Basically, if anyone says LOL in the comments, you know they don't know what they're talking about, especially if they are ROFL, etc., etc. Voxes should have a cut circuit. In stock form, usually from the output of the phase inverter, sometimes across a master volume pot, sometimes just going to a cut pot. One side goes to the cut pot through a 4.7 nanofarad cap, and the pot is 250K wired as a variable resistor, and it goes to the other side. So you have some variable form of resistance in a 4.7 nanofarad cap, and that just filters off the highs. And as you decrease the value of that cap, decrease that resistance, you have more high-end roll-off. And I have here emulated what happens in a cut circuit when it's at about 2 o'clock, which is a pretty useful, normal place for a cut circuit to be on a top boost channel. It's still plenty bright, but it just takes out the glassy ice pick. So that's a 68K, and I did not have a 4.7 nanofarad cap. I was out of them, so these are two 2.2s that I had in parallel temporarily, and I will redo this when I get the proper cap in, and I'll probably do it right here on the board underneath this ground wire. So it's a nice, neat layout right here. But just a 68K in series with a 4.7 nanofarad. Vox very easily could have and absolutely should have included that in this amp. Some other changes I've made to this amp include the filtering. They had 32, then 10, 10, 10, 10. So I've changed this to 20 so that we have less filtering on the initial stage. It affects the feel of how the EL84s behave. Then a 40, since this amp does not have a choke, this resistor is taking the place of a choke, but that does not give you as much filtering as a choke. So I have increased the capacitance here, increased the filtering here, where it doesn't impact the behavior of the output tubes very much. And then here, which is only used for the reverb circuit, I've given it a 20, which helps quite a bit. And then here and here, it's going to get 10s, but I was out of the 10s and the MODs. I'm going to order some. You can see that on the cathodes down here, and this capacitor here, and the bias capacitor here, I have replaced them all with these Vichys. That's because I know that these are quality caps, and the ones in there stock are kind of generic. And since it's been on my bench, I don't want this to have to come back on the bench for 20 years. So let's put in some caps that are going to last for the span. Now, crucially, like the AC-15, this amp had 100 ohm screen grid resistors, which is a value they inherited from the JMIs, which was a bad idea in the JMIs. They got away with it in the JMIs because they're using Mullards and Brimars. These amps are not using really high-quality tubes. 100 ohms gives almost no screen grid protection, and tubes suffer. So these were replaced with some 2-watt 1Ks, and that's much more sane. I'll repeat this for the AC10 part of the video, just in case someone skips ahead and only saw the AC10 video before. But I had mentioned on the master volume that they did not have the safety resistors here. That was a mea culpa because I had not drawn it out yet, and that's where you would normally mount them. They actually have those 2 megs here. So they do have the safety resistors. It's just a non-intuitive mounting. And that's fine now that I know that they're there. That's one less thing to worry about. So before we talk about the effects loop, if you have one of these amps, what needs to be done? Quote, needs to be done. Well, I do think you should take out that 220K resistor right here and replace it with either straight wire or a very low value resistor like this 47 ohm here. Gets you a lot more output available, a lot more range available to the volume pot. If they have burned these caps, change them. If they have not burned them, they are fine. There's nothing wrong with this part of the circuit. The addition of this cut circuit, even though it's a fixed cut circuit, is crucial, crucial, crucial. I strongly advise that, and see the third video on this when the parts come in, and you'll see how I think it should be done. It really makes the amp much nicer to use. These screen grids, change these to at least 470 ohm, if not 1Ks. That's crucial, crucial, crucial. Everything else I'm doing here is because it's here, and it's even mo better. But this stuff, really affects the longevity of your tubes and the performance of your amp and the reliability of your amp. It's a no-brainer to fix that. I don't know why Vox got that wrong. Now let's talk about the big issue in this amp, this effects loop and its physical placement. This introduces noise at all time. I have this bypassed, and it is introducing hum into the amp. I'm going to shut up for a second and turn up the mic level so you can hear the hum I'm talking about. All right. The reason this is humming is because this is a noisy environment here. The AC-15 and I assume the AC-30 have all their tubes on the other side of the chassis, so there's a big distance between the tubes and their heaters and this loop circuitry. In this AC-10, it's right over the preamp tubes and it's right up against the heater wiring, which is also under here. Now, I'm going to rotate this out. I'm going to leave it connected over here, so this will still be tied to the chassis as far as grounding goes, but allow me to swing this out farther away from the heater stuff, and this noise will change even with the loop bypassed. While the hum will go away, this is still prone to environmental noise, especially as rotated out, so you may hear the Wi-Fi router. So let me slightly loosen the screw. And bring this out and let's listen. I tighten it here. You can hear that there's still some signal coming in, some noise coming here. It's still subject to noise. But that hum is gone. And that hum, I think, is just proximity to the heater wiring, which is all in this area. And there's not much I can do about that. This should have been physically mounted up here, far, far away from the heater wiring, because as I move this back, listen. And as I turn, if I do it like this so that hum's gone, if I turn the reverb up, then the hum's only in the reverb. The reverb hum is not dependent on the tank, it's not dependent on the cables. It seems to be just part of the reverb circuitry as they've done it. And given the real estate that's in the amp, it's above my pay grade to go in here and finish Vox's homework for them completely. I think this is a good sounding amp without reverb, without the effects loop. Now, one of the things I'm going to do next is see if I could bypass this entirely. And first of all, I'm gonna go above and beyond on this first one, because this is the first one to be on my bench. I'm going to see if running shielded wires from this point to here and from here to here makes this less prone to picking up that noise, in which case the effects loop can stay connected and just don't use it because it is still quite noisy. And that noise is also, this is noisier than the one in the 15. Again, it's picking up signal, yuck from this area. If shielding it does not do the trick, if this were my amp, I'd say, well, I just won't use this gimmicky effects loop. And I won't turn the reverb up very often, or I'll just keep the reverb off. But I would just run the wire either above or below the board from here to here and avoid all this noisy area and have a functional amp with everything except this bad loop. So part of the reason I do this video is for the owner to see it. Normally I would not go to the great lengths of taking this entire board out and disconnecting the wire beneath here and the wire beneath here and running shielding just to find out how a company had made a mistake. But it's useful to know these things. And if there is a fix, even if it's a pain in the butt fix, maybe Vox can implement that in future amps, or at least techs can know, hey, if you want that noise gone, here's the best way to lower it. It'll never be gone with this loop design, but it can be lowered from what it is. But I would just say AC10s don't need an effects loop. AC10s don't really need reverb. Stick a reverb pedal in front of it. Anyway, that's me. So the reverb there just above noon is not too bad, but all the remaining noise floor of the amp, and with the effects loop out like this, is coming from the reverb. If I bring the effects loop back in here, then there's a increased noise floor hum behind everything. Other than that, this amp is sounding very voxy to me. So I'm going to change out this cap and clean this up, and I'll report back on my loop experiments. But I think it's just physically too close to the heater stuff. It's all bundled up and clustered up together, and it's just bad design. It's just bad design. Well, I hope you found this video entertaining, at the very least, if not informative. I think my verdict is the AC10 is not a very good amp. It's way overpriced. The reverb's noisy. The effects loop is noisy. I'm not sure that could be fixed with its current physical location next to the tubes. But if you have one or you really want one, you can bypass the effects loop entirely. Just don't use the reverb. Then you can have a very good sounding amp. And I showed you how to make it a little bit better. The 15, though. The 15, I think, is a very good amp. Is it great? No. It can be made a lot better. I will say that the build quality is higher than that of the previous AC-15 hand-wired model, the one with the fawn Tolex. This thing has some quirks. I think the placement of the speaker jacks in a combo borders on insane. What's wrong with them? The effects loop should have been quiet from the factory and still isn't as quiet as it really should be for professional use. But it's kind of one of those things. The marketing insisted that we have one, so here you go. A drop-in high-quality one, $75. So what do you think this thing costs? I don't think AC30s need effects loops. I don't think they really need reverb either, but the reverb sounds pretty good in this amp. So there it is. I would not worry about an effects loop with this thing. I'd make sure the amp is not being negatively affected by it. And the AC10, it is being negatively affected by the wires coming to this area. In the 15, when it's bypassed, it's bypassed. So, it's okay. Anyway, I could go on and on and on. That's enough for now. Thanks for watching.